Hello everyone, welcome to this video where we are given that when there are two quantities, x and y vary in such a way that y divided by x is a constant, meaning there's a fixed value. They are said to be in direct proportion. Or another word to use is directly proportional to each other. And that brings me to this topic called direct proportion. Things to take note about this particular topic would be how does the equation looks like. The equation of the graph looks like this. Y equals to k times x. K is the constant and k does not equals to 0. And it is a straight line that passes through the origin. Origin is this point here. Then when I plot it out right, what do you think the letter k is? Other than it is a constant. For those who remember, in another topic on linear graph, you can actually see that k is actually the gradient of this graph. Okay? And another important thing to take note before we go to the examples would be that in direct proportion, when one quantity, in this case y, increase, in this case here, for my example is y, then the other quantity also increases. So in this case is x. Okay, they both increase. So let's move on to some examples to illustrate this relationship between the two quantities. Alright, hello everyone. For this particular question, we are to determine whether they are in direct proportion or not. Okay, and therefore for this particular question, the very first thing is we need to check whether y divided by x for all the values of y and x, are they equal to a same number or not? Okay, is it a constant or not? Okay, so this is how my working looks like. So for y over x, I'm going to add on to this table. 21 divided by 3 is, so I'm going to divide, divide, it will give me 7. 42 divided by 6, 7. 49 divided by 7, also 7. This also gives me 7, and since y over x is indeed equals to a constant, then they are in direct proportion. So how do I write it down? So since y over x is equal to 7 is a constant, x and y are in direct proportion. Let's check for part B as well, okay? So using the same method, 30 divided by 8 will give me 3.75. 48 divided by 12. Oh, this gives me 4. So of course, I can continue just to make sure that the solution is complete. And therefore, I do see that, hey, there's one odd one out there, isn't it? So since y over x is not a constant in this table of values, x and y are not in direct proportion. Alright, and that's how you check whether they are in direct proportion or not. Let's move on to the next example. Hello everyone, welcome to this example where we are given a table that shows the number of hours worked and the corresponding wages. So for this, I'm going to zoom in. Show that T and W are in T and W. Where is T and W? T is here. W is here. Are in direct proportion. We learned that previously. So for this particular question, we are going to draw this table out. And we are going to draw a table that has T, W, oops, sorry, too thick, W over T, and that will be for all the values down there, okay? So meaning this table here, I would then have 150 over 10. This gives me 15. 300 over 20, also 15. 450 over 30 is also 15. Okay, let me just make sure that I got 600 over 40 is also 15. And the last one, 750 over 50, this is also equals to 15. And the moment you show that W over T is or the fixed number, they are in direct proportion. So we have successfully shown that T and W are in direct proportion. Express W in terms of T. So this will be something that for us to learn now. For direct proportion, T and W, or W over T, we know that they always equals to 15, right? So now we do need to make sure that W is equals to, what do we do with the T? Yep, we multiply. Yep. And that's all. That's what they want. Part C. If a worker worked for 35 hours, find his wage. So now I know the hours, T. So for this question, all we have to do, the wage will be equals to 15. It is always 15, okay? Times T. T now is 35. And this will give me a value of $525. And if I have his wage, find the number of hours. So again, if I know that 675 or 15 T is equals to $675. So how do I find my T? Yep. My T will be equals to 675. I'm going to divide by 15 to give me a value of 45 hours. For part E, Now this graph have actually been plotted here. State some observation you made about the graph when they are directly proportional to each other. The first observation is that the first one would be that it is a straight line that passes through the origin. Secondly, as in this case is W increases, the T also increases. With that, we have come to the end of this example. So if you like this example, do give this video a thumbs up. Alright, as we move on to the next example. Hello everyone, for this example here, we have a car that is traveling steadily along a highway, and we have the first quantity P liters. We also have the next quantity D distance, D kilometer, and they are directly proportional to each other. So therefore, for part A, because we know that they are directly proportional, we are going to make use of the general equation for direct proportion. So in this case, we would have Y as P, K we don't know, my X is actually my D, and we do know something though. They give us 100 kilometer and 8 liters. I'm going to substitute 100 kilometer and 8 liters into this general equation to find K. Okay, and so 8 liters, 8 is equal to K times 100. Therefore, my K will be equals to 8 over 100, which is equals to 0.08. And so for part A, the equation will be P is equals to 0.08 D. Done. For part B, now that we have the equation, right? We just need to substitute into the equation. Find the petrol that is needed, and I know it's 0.08 times my D. Now the distance is 60, and that will give me a value of 4.8 liters. Done. Part C. Find the maximum distance the car can travel with 40 liters, meaning now my P is 40. I need to find my D. So I will need to divide by 0.08. So finally, for D, the answer would be 500 kilometer. And we are done with this example. Okay? And we can move on to the next example. Now, for this example, we are given the following. Very importantly, it is directly proportional to x for my y and my x. And the value of y, we are also given, x also given, you know. So this basically allow us to find the value of k. So for part A, right, y is equals to kx. This is the general formula for direct proportion. And because we got the number 72, we also got the number for x, 16. So therefore, we are able to then find the value for k, which is 72 divided by 16. 4.5. So for part A, the answer, y is equals to 4.5 times x. Done. For part B, then find the value of y when x is 27. And we are done with this example as well. Hello everyone, welcome to this video or this example where we are given the following. This is important. First, we need to know whether is it direct proportion. The next thing is y and the other quantity. Do take note, it's not x. Rather, it is square root of x. This affects the equation later on. Okay? Meaning for A, right? Given the general formula here, my y is still y in this question. But my x for this question is actually square root x. Okay? And therefore, this does affect the values of k when we calculate it. So we are going to substitute them in. And therefore, we are able then to find the value of k. So k will be equals to 8. So for this, y is equals to k, which is 8 times square root x. Okay, do be careful. And once we know the equation, we can then find the value of y when x is now 81. And this will be 72. And we have come to the end of this example. Let's move on to the last example. Everyone, welcome to this video or this question where we are given that, very importantly, this is a direct proportion. And we have the mass. We also have the radius, but it is not only radius. We do need to take note that it is proportional to the cube of the radius. So for this table, right, you will then see Mr. Tan writing radius cube, meaning I need to find 3 power 3. This one will be 27. 4 power 3 will be 64. So that when I compare with my mass, which is 54, okay, so how do I find this question mark? Because I know they are directly proportional, this is an important info here, meaning that If I have this, I know that 27 times 2 is 54. Being directly proportional means that there is this same number that exists between the two relationships, and in this case is times 2. And so the question mark here will be equals to 64 times 2, 128. And we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day.